I'm Josipa Petrinic, the President and CEO of CUTRIC, and it's my pleasure to introduce my colleague Saumya Babsar, who's going to be moderating for the bulk of today, and he is our project manager on the hydrogen fuel cell electric bus demonstration project that we have labeled over the last few years as the Pan-Canadian Hydrogen Fuel Cell Electric Bus Demonstration and Integration Trial. Today, we're really going to be talking about the way forward in Mississauga to achieve a full fleet transition to zero carbon. And for those of you who have been part of the CUTRIC consortium for the last 5-6 years, you know that we started this project at the exact same time we started our Pan-Canadian electric bus project over half a decade ago. The electric bus project was complicated, but it got off the ground. It's out the door. We're collecting data. The industry is moving forward. The hydrogen fuel cell bus project suffered from a lot of cultural backlash at the time based on the experiences in BC with BC Transit and the Whistler experience. From that, CUTRIC dedicated a lot of time to overcoming those myths, to overcoming cultural inertia, and to really putting forward the best practices on hydrogen fuel cell electrified powertrain technologies and the opportunities for full fleet electrification. Our own modeling shows it's a necessary part of the electrification landscape. And of course, our clean grid in Canada demonstrates that clean hydrogen is a real solution available today to transit. So without further ado, I'm going to turn the virtual microphone over to Saumya, who's going to introduce you to our panelists and take you through this robust discussion today.
Thank you so much, Josipa. Welcome everyone again, and it's my pleasure to bring you on to the second fuel cell panel of this third annual Low Carbon Smart Mobility Conference. I'd like to introduce you all to our speakers for today, who'll be joining me just to discuss what this project means to them. Starting off, I have Rob Harvey, who's Director of Energy Infrastructure at Cummins. I have Stephanie Lobenstein, Director of Sales and Business Development from New Flyer and MCI. We've also got Steve Kay, who's Manager of Business Development from Enbridge. We've also got Terry Howe, who's Business Development Manager from Ballard. And ultimately, Stephen Bacchus, Manager of Transit Fleets from MyWay. Welcome everyone to the panel, and we're looking forward to hearing out what this project means to you and what you think this project means to Canadians. That said, we will start off the plenary panel here with a bit of a video introduction to the project. And so let's have a look at the audio-visual form of this project. If I can just let my colleagues put on the video. Yeah.
The Pan-Canadian Hydrogen Fuel Cell Electric Bus Demonstration and Integration Trial will mark the homecoming of hydrogen fuel cell technology in Canada. It will deploy 10 fuel cell electric buses in the city of Mississauga, coupled with local green hydrogen fueling solutions. As Canada moves towards its goal of deploying 5,000 zero-emission buses in the next 5 years, this project will lay a strong foundation for Canadian transit agencies to integrate a critical zero-emissions technology in their fleets.
What a hydrogen fuel cell bus means is it's zero emission. In other words, there is no particulate matter and there's no exhaust that comes out of the bus. What happens is electricity is created through a chemical process on board the bus, and the only thing that comes out of the tailpipe is water.
The project will deploy a long-term fueling solution to support operation of the 10 fuel cell electric buses throughout their life cycle. Green hydrogen will be produced at the Markham Energy Storage Facility, which is a central electrolysis facility owned and operated by a joint venture between our project partners Enbridge and Cummins. The hydrogen will be delivered from the Markham Energy Storage Facility using fuel supply infrastructure that has been designed to enable scaling with minimal incremental operating costs.
hydrogen fuel cell economy in Canada is truly a national job growth story. Everything from British Columbia's Ballard and Simon Fraser University through to Alberta with Luxford, through to Manitoba with New Flyer making hydrogen fuel cell buses, into Ontario around the hydrogenics economy, several universities allied to that, into Quebec around Trois-Rivières where there's a great deal of hydrogen innovation capacity. It is a job growth story for Canada, it's good for the economy, and it happens to be great for the environment.
Fuel cell electric buses complement battery electric buses for electrification of transit systems. They are more suitable for longer distance routes that are considered difficult to electrify using battery electric bus technology. The Pan-Canadian Hydrogen Fuel Cell Electric Bus Demonstration and Integration Trial provides a critical step in reducing greenhouse gas emissions, building sustainable communities, and decarbonizing our economy as Canada strives to build a net zero economy by 2050.
Minister McKenna announced billions of dollars to get 5,000 non-polluting zero-emissions buses out the door in the next few years. That's about 30% of our fleet, and it will eliminate almost a megaton of greenhouse gases from our local and global air at the same time.
Thank you to my colleagues for playing out the video. With that said, I would like to reintroduce the project in a bit of a different light, maybe delve a bit into the history of the project through a short presentation, following which we can then turn on to our panelists to further discuss the project. If I was to take us through this presentation, if we look at the first slide here, well, again, a quick reintroduction. What do we intend to do as part of this project? We intend to collaborate with MyWay, who's the champion transit agency, and deploy 10 fuel cell buses in the city of Mississauga, coupled with a local green hydrogen fuel supply chain. Now that's a new story in Canada. That's a bit of a unique solution and configuration that hasn't been done over the past decade or two or three before. And how far have we come on this project? Over the last few years, after a substantial amount of efforts, as far as this particular year is concerned, we've commenced a phase 1 feasibility study, which started in April. The feasibility study will finish April 2022. We also finalized a procurement specification, and we're moving forward to order these buses by the end of this year, depending on how government funding pans out. Who are our partners? As you heard out in the video and as I introduced, we have MyWay, the champion transit agency, again with a history of leadership when it comes to sustainability issues in transit. We've got Enbridge and Cummins collaborating together to supply fuel for this project, and we've got New Flyer and Ballard collaborating together to supply the rolling stock, that is the buses for the project. If we move on to the next slide here, well, on the next slide, just a bit of highlight on the fueling system. Again, fuel will be supplied from the power to gas facility, or the Markham energy storage facility as it's called, which is owned and operated by Enbridge Cummins. Fuel will basically be supplied to an on-site fueling station at the Moulton Bus Depot, which is owned and operated by MyWay. At the Moulton Bus Depot, the fuel will be dispensed into the buses, and it will be brought to Moulton using tube trailers. Now, this is going to be a long-term fueling solution. To reiterate again, it's going to be a solution that will be scalable with minimal incremental capital costs. It has been optimized and future-proofed already. And yeah, this sets us up for a long-term trajectory to incorporate more fuel cell buses, not only at MyWay, but also other transit agencies in the GTHA. Now, taking a step back here, how did we get here? And that's where some of the lessons learned lie. And so if we look at the next slide here, looking at the story of CUTRIC and this particular project, we started off in 2016 asking the question, why are we not going electric in Canada? 2017, we started asking, well, what benefits will electrification bring? And what are the challenges associated with electrification? That's when it was also realized that not all blocks can be electrified using battery electric buses. We need technologies to complement battery electric buses. It was CUTRIC's own modeling for a bunch of transit agencies in the GTHA, especially, that showed that not all routes or blocks can be electrified using battery electric buses. So we started looking at fuel cell buses around 2018. A lot more concrete action on that front. CUTRIC convened a group comprised of original equipment manufacturers and transit agencies. And then there was also a working group comprised of academic members. As these members came together and collaborated, one of the core problems that was realized was, yes, fuel cell buses are far ahead in the technology readiness level when it comes to the TRL scale, but they're not far enough ahead on the commercial readiness index. And so fuel cell buses are still faced with a technology value of death scenario, as you may have read in some literature. And it's one of those fancy phrases that basically indicates that many a promising technology does suffer a premature demise quite often when it comes to scaling and commercial readiness. Oftentimes, the technology value of death is overcome by public funding and public investments in promising technologies. And so, we started asking, how do we get these fuel cell buses on the road? Public investment, of course, has been viewed as a promising complementary solution alongside some private investments, considering the lack of commercial maturity of fuel cell buses to this date. But then how do we justify public investments? And to justify public investments, we need to present a strong case, and we need to put together a solid enough scope for a demonstration and integration trial. And we also need to justify the value of these technologies, not just to the stakeholders involved, but also to Canada and Canadians in general. And so, as we started looking at the road forward to deploy fuel cell buses, the policy and regulatory landscape was yet another important piece for us to look at. And fortunately, in early 2021, we've had the most promising announcements on this front to date. We've had announcements and commitments to deploy 5,000 zero-emission buses in Canada over the next 5 years, but we've also had a national hydrogen strategy announced by Natural Resources Canada. And as all these pieces come together, yet again, the question that we've been asking here at CUTRIC and along with our stakeholders is, well, how do we justify asking for substantial public investments? First of all, we do recognize that the project as we have right now has solid potential to create robust knowledge when it comes to the technical and commercial deployments of fuel cell buses. Secondly, it will also position not just one transit agency in Canada, but several transit agencies in the region to deploy fuel cell buses at scale. And ultimately, we have the potential to come up with maybe Canada's first smaller scale green hydrogen transit hub, which would be based out of Ontario as well. And so this does create a lot of strategic value for project partners, and it creates value for Canada and Canadians. Now, let's explore a bit of this value by just letting our stakeholders explain it best. And so if I look at the next slide, just a quick look at 4 key indicators of value. There's environmental impact, there's made in Canada jobs and clean economic growth, there's the promise of scalability, and then there's the investment context. And now I'd like to invite all of our project partners, starting off with CUTRIC, not my project partner per se, but the organization that I hail from. I'll start off with Josipa to, first of all, highlight what role has CUTRIC played in this project and what it means to CUTRIC, and ultimately what it means to Canada and Canadians. And so, Josipa, if you can take us, first of all, through CUTRIC's role on the project.
Sure, thanks so much, Salmia. And we are partners. Despite boss and employee relationship, I would say we are partners, you and I, in this project, definitely holding hands in an egalitarian relationship to change the world. So thanks for doing this. I mean, I think the basic argument for what was CUTRIC's role and what is CUTRIC's role is we came up with the idea. So it is one of the typical things we do at CUTRIC. We come up with the idea for a project like this. And while a hydrogen bus project doesn't sound new today, it was 5 years ago. It was hard, there was inertia, there was opposition, there was no naysayers. So we came up with the idea, and we came up with the idea of finding a couple transit agencies that would hold hands, take the risk, overcome that cultural inertia, and technically plan out to deploy a substantial mass of vehicles. And then now our role is to do the technical speccing with a core group of members through a closed door process, issue the memorandum of understanding that binds us all together, and then help that procurement process unfold. And once the buses are out on the road, our job is to make sure that the loggers on the buses and the loggers on the electrolyzers feed in the data and allows our team to analyze the performance of these vehicles against what the manufacturers said they would perform at. So that's essentially our end-to-end goal, and our role is come up with the idea, pull together the stakeholders, pull together specifications, go lobby for the money, get the money, help procure the stuff, and then monitor all the stuff on the road. And our goal ultimately is to encourage other agencies to follow suit and to join this collaborative effort going forward.
Thank you, Josipa. Well, that's a great starting point. And so, having taken the lead on this, I believe you convened all of the current stakeholders on the project at some point, and one of those stakeholders has been the city of Mississauga, MyWay. And so, with that, I'd like to invite Stephen Bacchus from MyWay to highlight, first of all, what role has MyWay played on the project historically, or at least right now, what role is MyWay playing on the project? And Stephen, if you can shed some light on that.
Sure, Samia. So just for some background information for those that don't know, MyWay does own and operate a fleet of 511 buses, which include both diesel and hybrid electric buses. And in 2019, pre-COVID, MyWay buses traveled 37 million cumulative kilometers and consumed 20 million liters of diesel fuel. So to answer your question, Samia, MyWay's role in the project is that we are the champion transit agency for the CUTRIC Pan-Canadian Hydrogen Fuel Cell Electric Bus Demonstration and Integration Trial. So we will be the ones operating the buses on specific MyWay local routes, and will be supported by all of the other project members and partners that are on this panel. So Cummins, Enbridge, New Flyer, and Ballard. So, in the MyWay Fuel Cell Electric Bus presentation yesterday, we spoke a bit about the project, but throughout this panel, I really hope to, provide some detail on the strategic importance related to environmental sustainability, operability, social equity, innovation, and ultimately job creation.
Sure, thank you, Stephen. So if we start off there itself, like in terms of environmental benefits and value, if you can shed some light on the environmental benefits of the project to MyWay.
Yeah, sure. So I ultimately believe that the environmental benefits provide the greatest value to this project. So just want to give you guys some background on on Mississauga. So in 2017, the city became a signatory to the Global Covenant of Mayors for Climate and Energy, which comprises of a coalition of 9,000 cities. So Mississauga is part of that in 2017. So fast forward to 2019, the city of Mississauga actually declared a climate emergency, and as a result, council approved a climate change action plan. And as part of the climate change action plan, our interim goal is to reduce GHG emissions by 40% by 2030, and ultimately 80% by 2050. So in order for Mississauga to achieve these targets, MyWay can't purchase any more diesel buses starting today. We do have hybrid electric vehicles in our fleet. However, we know that there will be a point this decade that we will need to transition to fully zero emission buses to meet this target. In preliminary analysis, we've identified 2028 to be the cutoff point where we will need to purchase zero emission buses going forward. I know 2028 does seem like a far time ahead, but given that we're essentially building and even rebuilding our existing facilities to accommodate zero emission buses, there isn't really much time. So overall, I'd say that given that the city, My Way contributes 70% to the city's corporate GHG inventory alone, decarbonizing our bus fleet is a priority in order to have any sort of meaningful, impactful change.
Thanks, Stephen. And so quickly though, ambitious environmental targets, how did you reconcile them with some kind of a strategic vision or importance in operating terms? Did you see this project contributing to operating benefits as well?
Yeah, that's a good question. And I think in terms of operability, we understand that there will be a labor and skills transition that will occur as our technicians and bus operators better familiarize themselves with the technology. As I mentioned earlier, we do have a limited number of hybrid electric buses. However, we don't regularly maintain these high voltage systems in-house. So essentially we are starting from fresh. And also in terms of operations, we get a lot of questions on the spec of the bus. Is there going to be a diesel auxiliary heater? And just working through the technical specifications, and New Flyer can talk about this later on too, we're not planning to have a diesel auxiliary heater. So this would further our emissions, but we also need to consider the trade-off between energy consumption and range. As you can tell from the previous presentations from CUTRIC yesterday, buying the bus may be seen as the relatively easier task, but coordinating and designing a fueling network is the more challenging part.
Thank you, Stephen. Well, speaking of the fueling network, actually, I'd like to move to Rob Harvey from Cummins, our fuel supply partners. Well, Rob, if I can pose these questions, pretty much the same questions, but get some perspective from you. First of all, if just to introduce yourself, if you can highlight Cummins's role on the project, and ultimately, what's the strategic importance of the project to Cummins as a fuel supply partner on this project, and how do you see Cummins creating value for Canada through this?
Certainly, thanks, Samia. Well, we're very excited to be part of this My Way or Pan-Canadian fuel cell electric bus demonstration and integration trial, and this will be the first in Canada. And as you said, we're teaming up with Enbridge to supply green hydrogen and the end-to-end fueling infrastructure to deliver it. And I agree with Stephen, as that is the challenging part. I don't mean to diminish the buses. The buses are, technology is marvelous and the technology is ready, but the fueling infrastructure is quite a challenge. Cummins is a global leader in the production and the design and development of fuel cells and large-scale electrolysis. And we have been doing right in Mississauga for the past 25 years development on both those hydrogen technologies, and have supplied OEMs and project developers with fuel cells and electrolyzers around the world over that time. And in a sense, we're coming full circle now with this project in Mississauga. It is strategically important to Cummins. Our Mississauga Center. Our Mississauga facility is a center of excellence for our fuel cell and hydrogen technologies group within Cummins. And I mentioned we design the PEM technologies for both fuel cells, trucks, buses, trains, and large-scale electrolyzers for the production of green hydrogen. We make the highest power density electrolyzer stack in the world with the smallest footprint, and it's a scalable platform. This project is a marvelous project. It's the first of a kind in Canada to showcase zero emission fuel cell bus fleet technology. And as we've seen with other demonstration projects we've done around the world, and indeed the Markham energy storage facility, you absolutely have to have a demonstration project to get it rolling. There's no better way to appreciate the advantages of a zero emission fuel cell bus than to get on and ride one. And from a transit operator's perspective, you can't do a transition to zero emission future on paper. There's been a great deal of work that's gone to CUTRIC and My Way, and this consortium has done to prepare for this project. But you truly need an integration trial, and a scale of 10 buses is a very good way to start. And your last question, Samia, was what's the value to Canada and Canadians? And a big one is jobs. And since the acquisition of Hydrogenics in September 2019, At Cummins, we've hired more than 75 new staff to the facility in Mississauga in research and development, in engineering, in production staff and operations staff, and also other staff functions, sustaining a thriving hydrogen technology ecosystem in Mississauga, which we're part of the core of, but there are other hydrogen technology companies based in Mississauga, and certainly in the GTA. Growing out the hydrogen technology ecosystem is a big advantage. And as we grow, the opportunities for growing the supply chain for manufacturing also grow. And finally, one important impact of local deployments will be the step to developing a green hydrogen hub in the GTA. And the Markham Energy Storage Facility is an important starting point for that, with the capacity that we have to supply green hydrogen and deliver it for my way and potentially other transit agencies for fuel cell bus deployments. But there are other players as well. And how an ecosystem grows, you need to start, and then you have producers that join in, like Cummins and Enbridge, and other producers in the GTA that can produce hydrogen and supply it to zero emission fleet operators like My Way. You've got to start, but the vision for the GTA with Ontario especially, we've got a very low carbon generation mix, particularly if you're running off-peak periods. It's 100% carbon free. That is ideal for producing green hydrogen, and we can supply zero emission fleets in the future.
Thank you, Rob. So you truly make it sound like, and it's a realization that it is truly a homecoming of hydrogen technology in Canada. Should we be able to get this project off and running? And well, you shed some light on the possibility of having a bit of a local green hydrogen hub seeding up in the GTA area. And speaking of hubs, of course, energy delivery companies are critical partners in hub setups. And so, yeah, I'd like to move on to Steve here. Steve is with here from Enbridge, and Enbridge partners with Cummins on this particular production facility as well. Steve, if I was to pose the same questions to you and get some perspective from you, first of all, of course, we'd love to hear a couple sentences on your role on the project, but yeah, if you can also share your perspective on strategic importance and value to Canadians when you look at this project.
Yeah, sure. Thanks, Soumya. Thanks. Good afternoon, everyone. It's certainly a pleasure to join you today. As Rob mentioned, Enbridge is providing the fuel supply to the project from our 2.5 megawatt hydrogen electrolyzer plant in Markham, Ontario, which is jointly owned with Cummins. Now, many people may know that Enbridge operates across North America and overseas, and that in Ontario and Quebec, we operate North America's third largest natural gas utility with over 3.8 million customers. However, many people may not know that we're also very committed to renewable energy. Since 2002, we've invested $8 billion in renewable power generation facilities with the capacity to deliver over 2,000 megawatts of net zero emissions power to customers in Canada, the US, and Europe. Now that equals the energy consumption of about 950,000 homes or a city the size of San Francisco. Now, corporately, we see this as a significant growth opportunity with over $2.5 billion of planned investments over the next 3 years. Now, hydrogen is strategically significant for Enbridge because it can be blended into our natural gas system to decarbonize our energy delivery. Later this summer, we're going to begin a pilot project in Markham to inject up to 2% hydrogen into our natural gas system. That blended gas will be delivered to about 3,600 homes and small businesses in the area, and will be the first utility in North America to do this. But there's also many other markets for hydrogen. And one of the best is the one we're talking about, the transportation market. And that's because it can displace diesel. And diesel, as many of you know, is one of the most expensive and carbon intense fuels in use today. And hydrogen fuel cell vehicles provide a complementary solution to battery electric transit deployments where range can be challenging. Now, this particular project with My Way will showcase the Canadian hydrogen industry's ability to fuel that transportation sector. It'll create skilled jobs in the operations and maintenance of the compression and dispensing facilities. It'll establish a scalable hydrogen fuel supply hub in the GTA that can be further leveraged by other fleets. And it will demonstrate that Canada has the knowledge, leadership, and skill to deliver green hydrogen solutions to the market.
Thanks a lot, Steve. So yeah, it looks like scalability, yet another resonating word here. And we end up at the chicken and egg problem quite often, as we have over the past few years. Speaking of scale, though, and yet again, this is where the technology value that comes in. We've got the fueling infrastructure piece, which has a lot of potential to actually lead to a premature demise of technologies like fuel cell buses, as has happened previously. We are in a new climate policy paradigm now, and we hope for the best, that we get the requisite support from public sector stakeholders to get these kinds of projects off the ground. That said, we also still need to focus on the prizes of the rolling stock, which is the end use segment, the buses themselves, because after all, scaling fuel supply infrastructure has to go hand in hand with ramping up assembly line capacity at bus manufacturers. And so, speaking of ramping up assembly line capacity, I'd like to shift the focus to our fuel cell and bus supply partners here. I'll start off with Terry. First of all, Terry, at Ballard, well, if you can shed some light, first of all, on what your role on the project is, but besides your role on the project, why do you see this project as important for Canada, and how will it help scale those assembly lines at bus manufacturing facilities, right, like New Flyer, and how will it also help you scale your manufacturing lines and your supply chain for fuel cells, right? How is this project so important for you, and ultimately, like, how does this translate to importance for Canada and Canadians? So yeah, Terry.
Thanks, Sami, and thanks for the opportunity. Ballard is, as part of this project, we will be providing our 85 kilowatt fuel cell modules to New Flyer, and we are a leader in the hydrogen fuel cell technology for bus, truck, marine, and rail markets. Globally, we supply our fuel cell modules to more than a dozen bus OEMs, and have over 1,300 buses operating in revenue service today, more than any other supplier. We have buses operating safely, efficiently, and reliably in hot environments like Palm Springs, as well as cold environments like Riga, Latvia, where, like Mississauga Transit, they'll be parking these buses outdoors, open to the cold weather environment without any issues. We've been providing fuel cells to the bus market for more than a decade, and are quite excited to see the growth that's now happening. We see it in Europe and the US markets. In Europe, for example, the fuel cell bus tenders have now shifted from the tens per tender to the hundreds, a real sign that the market acceptance of the value proposition for hydrogen fuel cell buses has begun to take hold. This particular project will be a first of its kind, and a start for the Canadian market with a true homegrown solution from a set of global leaders that are on this panel today. Our products are been developed and manufactured at our campus in Burnaby, British Columbia, where we have about 800 employees of our total 900 plus employees. This campus, we've been growing through employees and in real estate through the last few years. And we now have 4 distinct buildings in our local Burnaby area, one for R&D, one focused on production, a service training facility to support transit companies, service department, and the bus OEMs, as well as a logistics facility. In the last year, with respect to investing, we've expanded our MEA capacity about 6-fold to 1.6 gigawatts worth of MEA. That's about enough for about 1,500 buses or trucks. And that's in it to enable us to be positioned to be ready for when the real growth happens. This investment in capital and resources is really starting to attract significant partnerships and provides a base for Ballard to remain that global leader located here in Canada.
Thank you, Terry. So yet again, seems like a lot of discussion around the local hydrogen ecosystem. And yeah, when it comes to the strategic importance, I mean, we can't stress enough that a project like this and other fuel cell deployments in Canada, they will contribute to growth in the local hydrogen ecosystem. But then, if we look at the hydrogen strategy of Canada and an emerging hydrogen ecosystem, ultimately, just like Ballard does, we need players like New Flyer as well, who essentially bring together all these pieces by enabling mature end-use technologies for fuel suppliers to basically make the most out of. And so with that, I'd like to invite Stephanie Lobenstein from New Flyer as well. And pretty much the same as we did with all our other panelists. We'd also love to hear your perspective on the strategic importance of projects like these for Canada. And yeah, how do you see it creating value for Canada and Canadians? And Stephanie, your thoughts?
Yeah, thank you for having me here today, Soumya. Really honored to be part of this panel with all of these leaders. So, NFI is a global leader in mass mobility solutions. We have 90 years of bus experience and about 8,000 employees across 10 countries. Approximately 2,300 of those are in Canada. And we manufacture about 8,800 buses and coaches annually. So we also boast over 50 years manufacturing zero-emission buses. Our role in this project is supplying the New Flyer Excelsior Charge H2, which is our 40-foot hydrogen fuel cell bus. But also we're providing bus telematics, service, and maintenance support, as well as training and workforce development. These buses have a very robust design. They are commercially available today. They're eco-friendly, and as other panelists have mentioned, they have an extended range. So while they're commercially available, what makes this important to us is this project marks the first fuel cell electric bus trial with sustainable, efficient, and connected mobility in Canada, while considering aspects such as continuous workforce development and green jobs. So in essence, this project links all of the hydrogen technology developers within the Canadian ecosystem. We're very excited to be a part of
it. Thank you, Stephanie. And so since we're on the topic of buses, and we recognize the importance of public funding support. Like if I was to pose one of the audience questions to you here, well, in terms of pricing, how do fuel cell buses compare with battery electric buses? Is it possible for you to shed some light, even on the ballpark ratio of these prices?
Yeah, absolutely. I can talk around that. So we are seeing a growing interest in fuel cell technology, and the more interest you see and the more that you have the buses become adopted and commercially available, the better the pricing will become. But right now we are definitely still seeing a gap between a battery electric bus and a fuel cell electric bus. And so depending on the customer specifications, we can see that gap be, around the $200,000 to $300,000 mark, really dependent on what you're comparing to, right? Like the apples to apples comparison has to be similar. I think as we see this increased interest, we believe it's attributed to a couple of reasons. So first, this Excelsior Charge H2, it's a battery electric bus that uses the hydrogen fuel cell on board to charge the battery, which extends the range of the vehicle. So depending on the climate and the topography and the duty cycle, you can have a one-to-one replacement with conventional propulsion system buses. So that's one aspect you have to take into consideration with this pricing discussion. The second is agencies are gaining more experience with the hydrogen refueling procedures and time, as well as the cost and complexity of the fueling infrastructure. But as you just said, today there's a cost premium for both the bus and the infrastructure. But when we get pilot programs and they start to grow like this one, from 1 to 2 buses to 5 to 10 or 10 to 20, that they become part of the fleet, and the agencies can obtain enough data to evaluate the total cost of ownership and determine the best mix of zero emission buses in their operation. And so, you know, the goal of any of these pilots is to prove this out and increase that adoption rate and increase the forecast and the demand over the foreseeable future.
Yeah, thank you, Stephanie. So some important points there. And so with that, I'd also like to just invite all our panelists on stage together here. And yeah, it's really helpful, Stephanie. That does bring up a question about scoping demonstration. Like, what's an appropriate scale? And maybe I'll pass this on to Josipa. Looking at the history of this project, you know, what were the decision factors that brought us to this point of deploying 10 buses instead of maybe any other number? If you can share that.
Yeah, thanks, Samia. And I really think that our colleagues at MyWay and New Flyer will probably have some insight here too. But I'm going to draw like a black and white line, because we've heard this again, like, why should agencies go to 1 to 2 bus pilots to test the waters? So the scope of this project is 10 fuel cell buses to start with, because the intention is this is a permanent part of the fleet at MyWay, and that it is already scalable at 10 buses. You're already thinking about the systems implementation, the complexities, the facility, so that MyWay can go from 10 to 30 to 50 relatively easy in the grand scheme of things. So the 10 buses to start with are a fleet demonstrator that help them learn everything they need to know about the training, the facility, the fueling, and all the things that for sure will go wrong in a first deployment like this. That is necessary. But after that, it allows for that scalability fairly quickly. So, you know, the black and white line I'll draw is we have been over this over and over and over in the last 5 years. And we have, I thought we had quashed the idea that we should do 1 to 2 bus pilots, but that idea is coming back up like a weed. You know, I threw some water on my garden the other day and a weed grew, and I thought it was a tree. Apparently it's called the tree of hell, and it's actually a weed. So it's like that. It's like that weed keeps coming up. And the reason it's a weed is because you cannot easily deploy 1 or 2 buses in any meaningful way for hydrogen. The fundamental issue is you can't build the fueling supply chain, you can't plan for your facility, and it's not scalable. So it's kind of a waste of taxpayer dollars. And those pilots have happened. There's more than enough evidence from Europe and the US to pull on. We really don't need 1 to 2 bus pilots. We need 10 to 20 bus demonstration pilots. I'll leave it there because we're quite adamant about this. I'll turn it maybe to Stephen for your insights at MyWay as to like why MyWay is going with 10 and not 1.
Right, Josipa. So I think you know, the main reason why we went with 10 is exactly what you mentioned. You know, we can't have any meaningful data collection and data reporting on 1 or 2 buses. Just thinking about the reliability of these buses, we don't really know what they could be, especially in a Canadian cold climate. And having only 1 or 2 buses, and let's say one of them does go down, you're only stuck with 1 buses or maybe potentially even 0 buses at one time. I also want to mention about the whole hydrogen fueling infrastructure network. So we expect that hydrogen fueling infrastructure network would actually surpass the useful life, that equipment would surpass the useful life of a transit bus. So if we do want to scale up from 10 buses to 20, 30, even 40, we have the infrastructure already in place, and it's just incremental costs based on the huge capital costs we had to put up front. So that's why it makes sense for us. We're still working with New Flyer on understanding what type of data signals and what type of data we want to collect on the loggers to report. And the beauty about it is we have our colleagues over at Winnipeg doing the same, having the same idea, so we can share our data with them and compare data. So that's just the beauty about the industry.
Yeah, I think that's a great comment, not just about the number of vehicles, but also like the performance data for reasonability. And Stephanie, I mean, you guys have had a lot of experience in demonstrating fuel cell buses and getting them out the door. California is buying a lot of them. Can you give some insights here? Because the narrative keeps coming back to the 1 to 2 bus pilots, and we've been here already 5 years ago with electric buses.
Yeah, we have, and I tried to capture it, you know, in the last information I shared. But when we see these trials start to grow, they truly provide the right data for performance and economics so that you can confidently make decisions about what's right. It's not an orphan fleet of 1 or 2 buses. It's actually part of the fleet. And I think it also impacts some of the workforce development initiatives. It lets you understand, what do your maintenance and service staff really need? Do you want to be relying on us to do it? Or do you want to be bringing that skill set in-house, and do you want us to help train on it? Or what do we need to reach out to the industry in order to do? So for this project, we are bringing some aspects of workforce development. We're doing some training through our Vehicle Innovation Center. We're going to have boots on the ground for a prolonged period of time to help with maintenance and service and warranty work. But then we're also making some programs available that we're currently developing around pre-apprenticeship and apprenticeship programs for electrical technicians, because we believe there's a gap in the workforce there that we need to start training people on, both at our organization and through the whole entire industry in North America. So I think when you get to this level of adoption, it actually forces a bit more of those conversations so that you know what you have to go fill for this to be really successful long-term and get to that large scale adoption.
Yeah, thank you, Stephanie. And so speaking of large scale adoption, of course, the other important piece is the fuel supply side. And so I'll turn to Steve here. First of all, well, looking at scaling plans to go from 10 buses right now to 30, 40, 50 in the GTA area, do we have capacity at the current production facility to ramp up scale? How many buses can we fill with the current green hydrogen production capacity in the GTA?
Yeah, it's a great question, Soumya, and Rob may have additional thoughts on this too. But I can say that so we've done the front end engineering work to look at scaling up to as many as 40 buses, and the great thing we're seeing is that as you scale up, you achieve economies of scale and the cost per unit go down, which is fantastic. One of the things that we're working through at our facility is trying to avoid peak power pricing. So, to some degree, we're trying to stay with the off-peak hours. So theoretically, we could do more than 40, but 40 is a number. We've done quite a bit of work around 10 bus increments, all the way up to 40, and we can comfortably provide that at even better prices as the fleet ramps up.
And Soumya, if I may just add a follow-up there, Steve. Yannick CUTRIC asked the question there about like how much of the hydrogen at Markham will be used by this project. So basically like how much is left over for others. And then if you could add to that, what would have to happen if like Brampton joined in and took 10 and TTC threw in 10 as part of its 300 bus deployment? We got to like 50, 60, 100 in the next 2 or 3 years.
Yeah, no, sure. So, I mean, roughly the current allotment, if the plant were running flat out, the My Way project right now would use about 30% of its current capacity. The footprint that we have can easily, at the current facility, can easily double our capacity. So in which case it'd be using 15% of our current capacity. So again, that's assuming we're running 24 hours a day through all peak periods, but hopefully that gives you a feel for the answer there.
Sure. And Rob, any additional thoughts on that?
No, I think there's just the tension here. One of the objectives is to have green hydrogen. There are cheaper sources of hydrogen from conventional, SMR, but it's a zero emission fleet, and the desire is to have green hydrogen to fuel that fleet to maximize the environmental benefits. And Ontario, as I mentioned, we've got a very envious low carbon generation mix. When you're running off peak, you're running entirely on zero carbon sources. It's only on peak that there are carbon generation sources, gas-fired plants that will come on the margin. So when you marry the project with off-peak production. It also improves the economics of the hydrogen production from a cost of electricity standpoint. And as Steve has said, we looked at this for the initial project, which is the 10 bus demonstration and integration trial, but with an eye to what's the future requirements for a MyWay, a transit operator. They're looking for a solution that will allow them to transition to 100% zero emission fleet. And having a fueling solution that will just do 10 buses will not get you there. So we've looked at how do you, within the current design, how do you get to 20 buses and even beyond that. And the one thing that is tremendous about an advantage of hydrogen is that it scales really well. When you look at the scaling costs of going from 10 to 20 to 40 buses on fueling infrastructure, you get significant cost reductions on a delivered kilogram basis. The same cannot be said of battery electric buses. If you go from 10 to 20 to 40 buses for the charging infrastructure, actually it's working in the opposite direction. So that's one of the learnings from the front-end engineering design, and one of the things that will be demonstrated in the project.
I would say, Samia, perhaps one thing to add too is that there is not a homogenous national story here either, right? From the fueling side of the equation. Like if you're in Quebec right now and you're a transit agency, it's a really good news story for hydrogen. It's cheap electricity, cheap electrolysis, cheap hydrogen in the grand scheme of things. If you were to deploy, it's also very green. If you're out in BC, there's a narrative there because of an ecosystem. If you're in Alberta, as you referred to, Rob, there's a lot of steam methane reformed hydrogen, very cheap. So there's lots of different cheap sources and lots of very green sources. But if we can do it, and we can do it effectively in Ontario, it can be done anywhere in this country because the electricity market is the way it is, because the cost of electricity is what it is, and because there are currently no fuel cell buses deployed here. It's a real winner. It would set the precedent for the rest of the country because everywhere else it's going to be cheaper, including in Manitoba, et cetera, where we're seeing interest in this kind of deployment. And I welcome the feedback from our participants, but that's essentially one of our core goals here is make it work, make it cost effective and scalable in Ontario, and then it can copy, paste, repeat across the country fairly, I won't say easily because none of this is easy, but fairly reasonably without the complexities we're dealing with from an electricity standpoint.
Sure. And so that as we're approaching the end of the panel, maybe we'll do a bit of a round to summarize thoughts. So as far as next steps are concerned, I'll start off with Terry. Terry, as far as next steps are concerned, what is the last remaining barrier for a project like this and for similar projects in Canada, and how can we cross this figurative valley of death situation?
Yeah, so I think what we're seeing elsewhere is it's taken some time for transit agencies and municipalities to get used to the technology, to understand the technology, to accept it. So we have to get over that hump in Canada. I think that's happened in California, that's happened in Europe. We're just a little bit behind, and I think we need to make this a success, and then I think it will replicate across the country.
Sure. Thank you, Terry. And so speaking of barriers, we should also look at some opportunities. And so, well, starting with Steve. Steve, first of all, a few thoughts on what you see as the last remaining barriers, but do you also see opportunities to use hydrogen supply from the current production facility for other uses besides blending and besides the transportation sector? Are there opportunities to harvest waste heat from the hydrogen infra chain? So we have a question from Yannick Trottier. Are there opportunities to harvest waste heat from hydro infra? Example for heating buildings? Is that yet another opportunity that can expedite kind of the commercial deployment of hydrogen production facilities?
Yeah, so quickly, I believe we just have a few minutes left, but in terms of barriers, I think we're marching through those barriers quite well together. I think a coordinated team effort of Canada's leading companies working together here with the city of Mississauga as showing outstanding leadership to make themselves and Ontario a leader in hydrogen is fantastic. I think, we're speaking with the government, getting the federal government to be part of the partnership here would be tremendous to help get us through the final gate. In terms of opportunities for hydrogen, it's endless. There are numerous opportunities for hydrogen, and we are exploring all of them. Transportation is a leading one because it's displacing diesel, and that's fantastic. I mentioned the blending project. There are applications for hydrogen for power generation. There are applications for hydrogen in steel making, cement, turbines. It's many potential applications. So the future is very, very bright for hydrogen.
Thank you, Steve. And so Rob, if you'd like to add your thoughts to
Steve's discussion. I think we've had a lot of experience at Cummins, as I said, over 25 years. You can't pass go without demonstration projects. The fact that we could take you to show you a Karadia Island commuter train, fuel cell electric train in Germany is wonderful, but it's not going to help an operator here in Canada. A New Flyer in Ballard could take you to California, to Sunline, and show you buses and operations in sunny California. It's not going to help us learn about what we need to do in Canada with the cold weather and the operating constraints here to run it. The fact that it's done somewhere else gives us confidence we can do it here, but we need to do it here. And as a couple panelists have mentioned, the technology has been developed here. So I think it's a very exciting project. We need a first fuel cell demonstration and integration trial in Canada. And My Way has been working as part of this CUTRIC consortium for many years, and it's a great project. And I would love to see it get launched and off the ground and show the world how it works here in Canada.
Sure, thank you, Rob. And so your thoughts on it, Stephanie? What's stopping us, from having this ready and going in Canada? And what's stopping us from having My Way just get these buses on the ground now?
I don't think there's a lot stopping us. We just need to get through these last few pieces to move us forward. We have been working collaboratively on this project for a couple of years now. We've done some feasibility analysis. We've defined scope. We've gotten to the point that we all know what our roles and responsibilities are. We've discussed how we're going to mitigate risk and make this a successful trial. So now we're at that point that we need to move this forward, close up any funding that we need and make sure that we can come up with a launch plan that allows us to move this forward and do this trial. Because I think in the long run, the benefits are going to be fruitful for all Canadians. We're going to look at workforce development initiatives. It sounds like there's great opportunities for upscaling in some of the production facilities around the hydrogen. And I guess pulling it all together, we will get to move forward and provide this data back to the industry so we can see if there is a there, which we believe there is, to move hydrogen fuel cells forward in Canada.
Sure. And so your thoughts on the last piece in the jigsaw, Stephen? What's the last?
Stephanie made a good point about workforce development, and I think building on what Stephanie and Rob said, Hydrogenics Cummins is a facility based in Mississauga and an extremely valuable asset to the city. So this manufacturing will provide business opportunities with Cummins, within Cummins, and even local Mississauga and GTA based companies to supply Cummins with component products. So we've seen it with ourselves with Hydrogenics hiring 75 new staff, so that's good, Rob. And even our local bus repair shops who have reached out to us stating their desire and interest to learn more about the project and how they can assist us in our journey to zero emissions. Like some of them are on the line right now. I know MTB and NBC have a presentation coming up later this afternoon about bus retrofits. So when they work on our buses, similar to when our techs work on our buses in this new technology, they're also learning and hiring an evolving skill set. And this is essentially building the entire hydrogen ecosystem and network that we're inherently creating.
Yeah. So ultimately, I'll turn to you, Jasper.
Thanks.
we have to de-risk. We have to de-risk some of the last remaining challenges. Is there a way that CUTRIC can help with regards to that? And yeah, how do we get through this last hurdle?
Yeah, well, thanks so much, Sami, and thanks to the panelists. I'll conclude on a couple points. One is, I mean, we yammer on and on and on. So I think like nonstop advocacy until people give up. I think that is a real strategy and it works. But in any case, the key thing here, and we've been saying it for lots of years, is the scalability of hydrogen electrification is clearly there. And once we get to buses, it goes to coaches. And once we go to coaches, it goes to freight trucks. And that really, really big piece of the greenhouse gas emissions pie that has to be addressed through freight and freight transportation is going to be fundamentally hydrogen electrification. Not solely, not only, there's going to be a lot of battery electrification, but hydrogen is going to have to play such a key role there. So we envision this project as also being a gateway to truck electrification, rail electrification, coach electrification through hydrogen. And the last thing I'd note on this is that we did spend a lot of years, this group spent a lot of years looking at what happened in the Whistler trial. Where were the project management gaps? Where was the local supply chain gap? And we spent a lot of time making sure that this project does not have those gaps. So I'm very, very confident that once out on the road, this will be a groundbreaking deployment in Canada, and we will have a lot of agencies piggybacking on it without facing the ongoing challenges they faced in the last couple of years thinking about this technology. So thanks very much to all the panelists. Thank you to you, Salmia, for putting this together and for pushing the project forward. We are now back at that yammering stage with our federal colleagues to make sure we get the money into the project.
Awesome. Yeah, thank you. Thank you so much to the panelists. And I really appreciate your insights and support throughout. Thank you to the audience members for dropping in interesting questions as well. First of all, I apologize if I wasn't able to go through all the questions. I'd love to network with you offline, or of course, please feel free to reach out to our panelists directly. There have been a couple of really challenging questions in the audience chat we couldn't get to as well, and especially questions surrounding scoping worthy of debates. I'd appreciate just an offline conversation on that too. And so, yeah, we look forward to just more on this front and hopefully having a successful update in the months to come, either from CUTRIC or from any other CUTRIC members or from any other transit agency in Canada for that matter. We look forward to the growth of this particular technology in Canada as well. And so, yeah, thank you again. And we will see you at the rest of the panels at the conference.